Welcome to Data Brew by Databricks with Denny and Brooke. The series allows us to explore various topics in the data and AI community. And whether we're talking about data engineering or data science, we're going to interview subject matter experts to dive deeper into these topics. This season, we'll be focusing on large language models, or LLMs, while we're enjoying our morning brew. My name is Denny Lee. I'm a developer advocate at Databricks and one half of Data Brew.
And hello, everyone. My name is Brooke Wenig, Machine Learning Practice Lead Director at Databricks and the other half of Data Brew. And today I am thrilled to introduce David Talby, CTO of Jon Snow Labs, to join us here today. Welcome, David.
Thank you for having me.
So to kick it off, what is Jon Snow Labs?
We are a software company. We've been around since 2015, and we've always focused on healthcare and life science. And we are most well known by far for the SparkNLP open source library, which we created. That's our baby, and we still support the community. SparkNLP has grown to more than 50 million downloads now, and it's very widely used kind of across really most companies worldwide. But it's completely free and open source. On top of it, we have our main commercial products around healthcare NLP and visual NLP, and we're the majority provider for understanding clinical or biomedical text for the healthcare and life science industries.
Yeah, and I have used SparkNLP a number of times on customer projects, particularly in healthcare. It's the leading offering out there. But before we get too into the technical details, I'm sure many people are wondering, why the name Jon Snow Labs?
Yeah, so the name has surprisingly really nothing to do with Game of Thrones. Dr. Jon Snow, although we are friends, but Dr. Jon Snow is an actual historical figure. He was a physician, a doctor in Victorian London, and he's considered the father of epidemiology. And the main reason he earned that title is because he's credited with helping end a cholera epidemic, which struck the Soho neighborhood of London in 1854. And as the story goes, he, while everyone else fled away, he actually went house to house and built a map of all the people who died. It's called the ghost map because every point on the map is a ghost. And he deduced that the most likely source of the outbreak was one water well. And he made a pitch to shut down that water well, and that really helped end the outbreak at that time. And the interesting piece here is that at the time, it was not known at all that cholera was waterborne. Okay, so that was really kind of the big insight, because and really people argued with him, right? So people said, look, we'll take the pump down. Don't start telling everyone this is waterborne, because you'll create public panic, and really we have no evidence to your crazy theory, because the microscope was only invented 30 years later. But this is really one of the first examples of using data in a very direct way to improve public health. And this is really the inspiration for Jon Snow Labs, right? I mean, we really, all we want to support the 21st century Jon Snows, right? So all the people who want to use data, in this century, right, to help improve healthcare. And, for us, those are the heroes we help push forward.
Yeah, and one of the fun facts about that story about Jon Snow actually is one of the reasons he was able to determine it was waterborne is all of the people that worked at the beer factory who predominantly drank beer weren't getting sick because they were drinking beer instead of water.
Yes, of course. Yeah, so there's a lot of beer in that story. Yeah, so first of all, yes, the beer factory is right across the street from the water pump, which was popular because it was popular. People came from other neighborhoods to the water pump because it has kind of cleaner water than others. But yes, apparently if you drink beer, you're always good, yes. And if you work at the beer factory, you get free beer. And that was one of the, yes, everybody is healthy. Another interesting fun fact, in the whole neighborhood of Soho, from 1854 until today, there's only one business that operated then and still operates now. And it's the local pub. And the pub was renamed the Jon Snow Pub. And actually, if you go in, I went in, I did a pilgrimage. There are images about the story and all of that. But if you're ever in London, you try the Jon Snow Pub. It's nothing fancy. Just your classic neighborhood pub. But it's been there for quite a while.
So for everybody that's currently listening to this, Vidcast podcast, I believe what we're trying to teach everybody is that drink beer instead. I think that's the lesson learned. Is that the context here?
That is the context. And look, and by the way, look, I mean, if you notice, in the Middle Ages, one of the reasons beer became so popular was because it was safer and healthier, right? And it was just easier to get than water, right? In many cases, yes, that was an option, absolutely. Yes, and that's if you remember one thing about healthcare from Jon Snow, drink more beer. It's a contribution to public health.
So, how appropriate that we decided to have this discussion on data brew. Okay, let me switch gears for us back to large language models. But let's talk a little bit. What the first question I want to ask is what has made Jon Snow Labs the most popular NLP library in the enterprise? Like especially since you've been part of that transition where so many enterprises actually have been working with Jon Snow Labs for NLP. I'm just curious why have we seen that growth for here?
Yes. Yeah. So basically, O'Reilly does the annual AI in the enterprise, and yes, for 5 years in a row, SparkNLP has been the most widely used NLP library in the enterprise, and through many transitions, right? So we started really a year before the BERT paper came out. Okay, and really what especially with LLMs today, what I keep telling people, when we started, literally no one cared about NLP, right? It was such a, an academic, uninteresting niche. And it really something. It feels like we were alone on the beach playing with our building a small a small sand castle, and then a tsunami came, and now the beach is full with people, and it's like, okay, cool. But that's been the past 6-7 years for us. Look, I think the main reason is that our commitment to the open source community and to the industry, to our customers, really our one commitment is that we will keep you the state of the art. Okay, so if you look at SparkNLP, it's not even necessarily a Spark solution. It's not necessarily a deep learning solution, right? It's not about the scale. Really, the main thing we promise is, look, every day we wake up in the morning. Every day there are new papers, new open source libraries, new models, new ideas. Our job is we test them. Most of them don't work, right? I tell you, work in healthcare, half of the papers don't reproduce. From the ones that do reproduce, a lot of them don't generalize, right? So you can say, yes, you achieved them, especially with CDs in healthcare. On this set of patients with these academic benchmarks, we're doing slightly better, but we have a much larger set, and no, this is not actually better on the broad. But if something is better, we will give you, really, we productize, right? So our job is to give you the production-grade, trainable, scalable version, right? So the BERT paper came in November 2017, and then in March we were on stage, also started data at the time. We said, look, here is name entity recognition and text classification with BERT, right? And here's how accurate it is, right? And then the architectures themselves change, right? So the embeddings change, and you have multiple types, and multilingual ones. Then you had the if you kind of fast forward, right? So last year you had the few shot, we had zero shot learning, right? So zero shot name entity recognition, zero shot relation extraction, and now really we have we're the first with healthcare specific large language models. So I think really, when you have an open source project, it's like most of the times, you put it out and nobody cares. Sometimes you put it out and you hit a point at a certain point of time. But I think when people really take to a project is when they see over, really, for now we're in the 6th year of releasing software every 2 weeks, right? And people obviously look at what you're releasing, right? So especially with enterprises, right? You want to see you have a project that it's there, it has a real community, right? It has a real team. When you have questions, people respond to you, right? People fix things, and mostly when you choose a software platform, you don't choose it for what it does now, right? You choose it because you want something to be reasonably future-proof. I think really that's really our main promise, and the main thing that we keep promising to the community.
Yeah, and I think one of the things that also really makes SparkNLP stand apart from others is the domain-specific NLP library, so healthcare, legal, etc. Can you talk a little bit more about the importance of domain-specific NLP?
Yes. So look, language itself, if you look at natural language, is super domain-specific. To the point where if you look at it from a linguistic perspective, we all use many languages every day, right? So the grammar and vocabulary that I use now with you is not the same one that I use when I talk to my kids, and it's not the same way that I use when I talk to my wife, and it's not the same way when I use when I email my team, and it's not the same one I use when when I email a customer, right? Or when I write when I tweet, right? because really those are different social contexts, right? But if you look at it, the grammar is different, the vocabulary is different, the intent is different, right? Within a healthcare setting, also healthcare is even more extreme because, for example, the three of us, if you want to look at your pathology report or radiology reports, you literally cannot read it. Okay, and if you really want to understand radiology report, you need to go to school to do it, and it probably take you longer than if you decide to learn, Russian or Japanese, right? It's kind of the gap is bigger, right? Because if you want to learn Russian, I can tell you, look, the word apple in Russian, here's the word. But if you want to understand, dermatology or endocrinology, you don't even know the nouns and the verbs, right? It's like, what is this condition, right? What is this procedure, and why does it need a different word, right? So in healthcare is its own really a few hundred languages. That's really the way to look at it. What it means from a technical perspective, if you want to go beyond keyword matching, right? Yeah, of course you can have algorithm that says yes, sure, match keywords and do like super simplistic grammatical stuff. If you really want to understand things, right? Show me all the patients who are, late stage breast cancer patients who are AGR negative and have not yet started on any sort of immunotherapy, right? Well, all of these are groupings, right? You will not have the exact words in the text. Not only do you need separate language models, also you need like sentence splitting is different, right? Tokenization is different. Spell correction is different. Of course, things like speech to text, question answering, right? They're all different. It's super interesting from a linguistic perspective.
That's really cool. Then I guess this sort of may naturally segue to LLMs. I mean, that's the current hotness, as they would say, right?
No, never heard of them.
No. I guess the context from from your perspective, like what is your approach toward it? Like, in terms of like how to address it. Like, there's all sorts of just like you sort of called out, like when you talk like a domain specific language, in essence, it's its own set of languages in the first place. How does that translate well or not well when you're applying this to LLMs versus NLPs and whatever else for that matter?
Yep. So look, we're doing a lot of work on LLMs, and I said we've released some of the first healthcare specific LLMs, and really for us, it's kind of really it's no different from when deep learning came, right? We come and say yes, we have a software. The previous software we have is no longer state of the art, right? Because that's the one challenge. When you say you're doing state of the art, you really have to keep running, right, and re-implementing, right? So now if and where this is better, yes, we will give you the better choice, and there are definitely things that LLMs do better. Right, mostly around things like question answering, around text generation, right, and really just the ability to be able really to paraphrase, right, and customize, understand context, right, customize text in very interesting ways. The other thing that LLMs do really well is that they enable, they take the whole concept of understanding text from data scientists to end users. Right, so now we ChatGPT the expectations look like why can't I just ask you for stuff, right? And if you look at really if you look at even the core business of Databricks does, right, which I ETL the data and then I build SQL and build dashboards and all of that, and if you look at it from an end user perspective, look, instead of like emailing my business analyst team to do the 3-page SQL and understand and send me the results, why can't I just like send that email to ChatGPT and just get a response, and just bypass this whole black box of whatever it is you guys do. So there's this expectation. Of course, we're not quite there. So what we do, we look. We've trained, we've tuned. We look at a whole number of kind of models and approaches. And here's what we see. So there's definitely the new capabilities we released. Probably the most popular one is summarization of medical text. Okay. And it's popular because there's there's too much data everywhere. There's also too much data in healthcare, right? So the problem is, if I'm a patient, I go to a hospital and I tell the doctor, look, I have it. Here's like my 200 pages of documentation for the last year. Just kind of just look at it and kind of say, let's start from scratch. Just tell me why you're here, right? Because really no one has time to read it, right? And understand what's going on, right? So there's a lot of this stuff that never gets used, right? Which you want to. We have also different LLM that are instruction tuned to do different things. So right now we have different models to summarize clinical notes. We have different models to summarize biomedical papers, so research papers. We have another model to summarize questions from patients, okay? Because kind of normal people who are no doctor, they use a different language than doctors. Yeah, and actually just today we released another model specifically to summarize radiology reports.
Oh, sorry, I had to ask a question because you just reminded me of something, so I apologize for interrupting. Then, by any chance, do you actually have a model to summarize all the LLM research papers so you can actually go ahead and figure out which ones are better or not?
Well, actually, we have some of them. No, the problem is then you have disagreement between the people on our team on what's most important. And by the way, that's another of the challenges in healthcare is that we have a whole team of doctors on our team, right, to do clinical validation, right? And it's one of the things in healthcare is like, you have 3 doctors, you're going to have at least 4 opinions. So we see the same thing. Oh, what's the best way to treat a patient comes in with this diagnosis? And then it's like the data science look at the response from our own team of analysts. Like, let's move on to the next question. We're not going to get out of this one, and nobody's going to agree this is correct. So that happens. So with us, like, look, like right now, for example, what we've showed is a model we've tuned on top of BioGPT. So BioGPT is a model released by Microsoft about 3 months ago now. When it was released, it was state of the art in terms of PubMed QA, so answering biomedical questions. And we've tuned it, and we were able to show that really on question answering, not just on biomedical questions, also on kind of clinical related content, it does very well, and we have some benchmarks there. In general, what we are seeing are, I would say 2 things. First of all, really, as you'd expect, as amazing as GPT-4 and ChatGPT are, in which they are really amazing, and really what they do specifically for healthcare, given they were not specifically tuned for healthcare, is outright amazing. But with all that, when you have models that are tuned for healthcare, they just do better. Okay, and and if you've been doing anything in machine learning in the past 15 years, this is like no surprise at all, right? It's like really take any baseline of a model and just give it more data tuned to the task that you actually care about. Yes, it's going to be more accurate, right? And I think really a lot of what happened is really because all of this is so new. People just assume, oh, now we can have these big models and basically they may be able to do everything. It's like, yes, they can do everything, but still, if you give it more data, if you tune it to a task, it's going to be significantly more accurate. And we publish kind of benchmarks, and when we publish benchmarks, it's blog posts, but also it's in Python notebooks. So, people are welcome to, rerun it yourself. Let us know if you think the benchmark is wrong, right? We should try other things, different metrics, please do. And I would say we give free software to academia, where people sometimes do, which is great, right? So we actually make progress as a community. But we see, for example, that if you do mainly information extraction tasks, so recognize medical entities correctly, mapping entities to kind of to medical terminologies, de-identification, right? Those are tasks where you see, yes, what we have now is significantly more accurate. And I think what we expect LLMs kind of to get better, but then also the healthcare specific ones would get better as well. The second thing we see is that one of the areas where we add value is, of course, like we have more data, but also it is the instruction tuning. Because, for example, as mentioned, today we publish the models to automatically summarize radiology reports. Okay, and the reason you need a separate model there is because summarizing a radiology report is not like summarizing a news clip, right? There are specific clinical facts that you need in the summary, right? And it doesn't matter if they were at the beginning or bottom of page 2, right? Same thing, like, for example, if you have a clinical note and you start it, the first sentence is always like, who is the patient and why they're here, right? So, this is a 76-year-old woman, right, coming in complaining about insomnia. Okay, right? And this is the most important thing you need to know about. So even like if, for example, the person's age was in page 3 of the original document, right? That's something that specifically need to know is clinically interesting, and you need to put it here, right? And when you go to different specialties, right, or when you look at other questions, like questions about medications, question about genomic biomarker and precision medicine, you really need to understand the question, right? So if you ask an LLM what's the capital of France, it's like, okay, it's we understand it, right? But if you ask, tell me how you treat the usual side effects of asthma, if you know that a doctor is asking, you need to answer in a certain way, right? There are certain facts they care about. So we see that as well. Yes, and we'll so those are kind of some of the interesting things we are there. I would say other than that, the other thing we're seeing is from customers. We're seeing that there are specific things that the current LLMs don't cover. And I think for healthcare and life science, are going to be, just like everything, they're going to be industry-specific solutions that people who care. And I mean, if that's of interest, yeah, I can cover that as well.
Yeah, I think it's impossible to talk about healthcare and machine learning without talking about data privacy. And so really curious about how you curate that training data set, how you continually update the models while keeping data privacy, HIPAA, all of that in mind.
Yes. So with Johnson Labs in general, yes, in healthcare, that's one of the reasons some of our customers just use us for that. But in general, for example, we do nothing as a service. Okay, the only way to use our software, including the LLMs, is here's the software and the models. Take it, you install it to your infrastructure, right? And of course, we make it super easy if you're on Databricks or AWS, right, or Kubernetes or some of those models. But it runs on your infrastructure, behind your firewall, and we never even see it. So it doesn't call home. You don't send your data to us. You don't send it to anyone else. Okay, and first of all, I believe that's the right model. I don't think that a healthcare organization should share their data with anyone. Okay, I mean, I personally dislike the fact that my credit card information is visible to like 6,000 organizations in the US. Right, it's basically public information. I don't think we should gather with my with my medications. But more than that, in healthcare, to a large extent, it's simply illegal. Right, so if someone wants to upload a patient record to ChatGPT and ask a question, it's just outright illegal. Even if you are dealing, you do have the checkbox and says, oh, we can use it for further training and other thing, it's still illegal. You need the patient consent to do that. And you have cases where you have some data sovereignty laws. It comes along, if the data is in Singapore or in London, it has to stay within the physical confines of that country. So one of the things we can tell our customers is, look, your data is your data. We don't want to see it. It's not our business model to share it or to train on it. On none of that. You want it under your secure and control, whatever they may be, and we require no admin privileges, none of that. So that's something that's super important. Honestly, I would hope that more organizations would act that way, right? Because I think in other industries, the model is kind of, if you use my services, you also kind of give me my data and I can use it to train and do other things. I don't think that's the right model for healthcare. I can also say that also, as after being in the business for a while, you don't need all the data to train state-of-the-art models. You really don't. Because healthcare, it's not much of a big data problem. It's a bunch of there's a very large collection of super small data problems, right? So if you want to understand how to extract a specific biomarker that's only relevant in this specific kind of colon cancer, you may have 500 patients a year in the US, right? That's it, right? And that's the thing in healthcare. The challenge is in the just the variety, right? That really each patient really is different, right? I mean, if you talk to doctors, they tell you that it's true. I'm 30 years in the business. I see new cases, right? I see new cases. The hospital, I see new cases, right? It's like it never ends. So privacy for us, yes, I can tell you all the software, it's designed from the ground up to run in air-gap environment. It does not need an internet connection, right? You can install, you have like 12 supported platforms. You can install wherever you want. It just runs there. And it does not have any impact of accuracy or anything else. In terms of updates, we update the software, every other week. But then people decide when they update, right? So some people update really as soon as it comes. They just load the models. It's a one-liner. Some people, especially in certified environment, right? If you have a software as a medical device, like you have a GXP environment in pharmaceuticals, they have a process of anything that comes that is deployed into an environment. So it's kind of say, yes, it's one line to move it, and 500 pages of documentation to to say that we moved it, which is no, it really is. You do get into this kind of stuff. What else those 70 people do? They document what we deliver. It's like, no, really, yes, really. And then like if you go into it, they really do, and they all have actual full-time jobs. It's unbelievable. What happened in some of these places. But yeah, we just build the software.
I would love to transition a bit into responsible AI and how Jon Snow Labs is approaching responsible AI.
Yes. So responsible AI is obviously, I think it's as big a trend as, maybe it's not as public as LLMs, but I think in terms of getting things to be implemented, I think it's just as important. I would say, not just in healthcare, but say definitely in healthcare, I would say all of our customers, most of our progress, they're concerned about not new legislation that's coming, but the current regulations. Okay, so currently, if you have a system and you have not tested it for bias, right? So the system performs differently on men, women, white people, black people, fat people, thin people, rich people, poor people, disabled people, diabetic people, pregnant people, Hindu people. You're breaking the law. Okay, and you will get caught, and you will get sued, and you should. Right, and really just in many other, in HR, there are all the existing protections, right, and companies who've deployed AI models are getting sued. Consumer protection, it's the same thing, right? Like in banking, right, you cannot offer one interest rate to black neighborhoods and another one to white neighborhoods, right? Even if a super smart algorithm did not explicitly decode rates, it just turned out that way, right? Just plain illegal. So for us, we are highly active in this space in two places, the kind of the low level and the high level. On the low level, a month ago, we've released the open source NLP test library. So it's Apache 2.0 license, completely open source, can do pip install NLP test. And the goal there was to solve a very simple problem that when people talk about responsible AI, basically everybody has the same beautiful slides, right? And they come and say, we have a holistic approach, and our AI, it's ethical and it's human-centered, and it's great, it's fantastic, and you have like nice, natural green colors. But then as a data scientist, you come and say, look, I trained the model, like what do you want me to do? Right? Like, what do I actually do? Right? So most people still go with the, best F1 score, right? Maybe they kind of, check a bit for overfitting. But with the NLP test, we come and say, no, there should be several dimensions or categories that you test. And right now, the library comes with more than 50 test types. So we test accuracy, but we test bias, we test fairness, we test representation, and we test robustness. Okay, and what we can do, we can automatically generate tests because we have some generative AI. We can run the test, and we can also do data augmentation. Okay, so for example, if you have a sentence, right, like, the boy read the book, and we can automatically generate variants, right? We say, oh, the girl read the book. Okay, the poor boy, the immigrant boy read the book, the Muslim boy read the book. Okay, we change countries. So for example, country names, we have a list of high-income country, low-income country. And it's very interesting when you have a sentiment analysis, right? The speaker is from Italy versus the speaker is from Syria, right? And you just see on bottom the neutral sentiment, like they're not, right? Question answering, where you have really based on just really outright stereotype and prejudice, things don't work. Definitely, if you change John Doe, went summer, or Jane May went summer, right? The entity recognition, relation extraction still work the same way. But today, even simple robustness, I would say the first thing we did, wanted to test the system. We took the most popular model on Hugging Face, okay, which is BERT-based case. Okay, and we said, let's test it for NER. And we ran a set of tests, and we said, okay, here's the robustness test. Take the string and turn it into uppercase. Okay? It's like not particularly, it's not like, paraphrase it, change it to a question, change it, temporal from past to future and see that it works. And accuracy dropped by 30%. Okay, so, and that's really one of the things that I've learned is that really right now the baseline in terms of really just robustness, fairness, bias is horrible. Okay, horrible. If you read the academic papers, the one thing that's common to all of them, if you look at the discussion section, they all have the similar sentences, which is, this is very concerning in terms of, biases, but not very surprising because this is the first paper ever to test. Right, so right now, really, we're at the point where, like, in the 80s or the 70s, like, there was no software testing, right? You wrote some code, and then you ran it, and you did whatever, right? And then you pushed it, essentially you push it to production, right? That was the code, right? And then at some point, we got the brilliant idea that, you should probably test your software for, edge cases, and, and really for whatever it is that you want to make sure it actually does, and if you haven't tested it, there's no surprise that it doesn't, right? And then, of course, there's a whole philosophy that goes with that, right? So now with NLP tester, our goal is to get to a point where we have this free tool, and either we can generate tests for you, or you can also edit them, right? Sometimes, especially it's question answering, you want to do it manually, but then you have a set of tests. They're human readable, so you can actually show them to a regulator, or a tester that's not technical can write them. It's a versioned file, okay, like any unit test or data test, right? and you can put it as part of your ML flow, right? You can say, oh, I have a new version of the model. Okay, just run it through the test, just like unit tests. You can set pass bars. You can say, oh, I want to have, at least 80% of the, robustness score, right, fairness score, toxicity score, whatever may be the case, pass, right? And that's how it goes. So that's our goal there. It's just getting started, but really, we're getting really nice collaboration from also other companies, other industry. So I understand we have more than 50 test types in 5 categories. It's going to double in the next 3-4 months. Just the number of test types, and we already have, I think, like 10 or 11 categories that we know we want to test to really be comprehensive. Just this week, we've added support for OpenAI models, right? So we can do question answering and test robustness for OpenAI. And really the work has been more fundamental to support LLMs. So now, really we're going to be able to support anything within LangChain very, very quickly. So you're able to compare those LLMs. So that's some of the work we're doing really for the open source community in that space. And of course, also internally, we're testing our own models, right? Because the other thing is we need to be able to tell our customers, our model are actually, our production ready. I think one change that I think will happen in the industry over the next 2-3 years is that people will stop using basically academic models, right? So if someone, published a paper and come say, hey, I put this thing on, on Torch Hub, right, or Hugging Face, people are going to stop using this production system, right? I mean, they're going to tune it. I mean, it's still useful. But some of those models are really, really unsafe, right, for production use. So that's in the kind of lower level of actually giving people tools they can use for NLP. On the other side, on the policy side, there's a fairly new coalition. It's called Coalition for Health AI. It's an organization that's 1 year old. It has co-founders from, I believe, from Mayo Clinic, from Duke, from the FDA. And actually, just yesterday, I came back from North Carolina. There was a kind of an in-person meeting, about 80 people, to start work on 5 different work groups, with the goal of really providing, and this is really, I mean, it's very impressive, just the connectiveness. So providing the White House, providing the American Medical Association, basically with the more detailed guidelines on how healthcare models should be certified and validated before they go to production. And I lead the fairness and bias mitigation work group out of the 5 groups there. So that's our focus there. And that's really more at the policy level, right? So starting really, how what you do from before project begins, what you do with project monitoring. So that's also, I do it, and also we have a small team within Jon Snow Labs that helps there. But that's a coalition, so really we have people there from, people from Google, from pharmaceutical, from academic medical centers, right, from, so still looking for a person from a community hospital, but the goal really is to have a coalition that puts that together. Because doctors, they're not used to, if you're a medical doctor, for example, when Jon Snow was a medical doctor in the 1840s, he invented a system to give ether to people, right? Because ether was the first anesthesia thing, okay? Right, so if you need to do surgery, your options were nothing or alcohol, and ether was so much better. The problem is it tended to kill people, because it was super easy to overdose. Okay, so if you just put the thing on your face like this, not good.
Minor technicality, got it.
Yes, exactly. It's like, 80-90% success rate, really good. Okay. But 10% of people, and then they're dead, they don't pay, it's not very good for patient relationships. So he invented a system that had it was fairly simple, but the point is he invented the device. Okay, because back then there was nothing, right? It's like you needed something, like, if you wanted to have a surgical knife, you went to your butcher, right? And then you went together to the blacksmith and comes, look, I want it like this, but can you cut it this way? You cut it yourself, right? You build your own instruments. But now in the last 100 years, with the FDA, with the, with mass production, right, with scientists, that doctors are used to the fact that, if you give me a medication or a medical device, someone has actually tested it and it actually works, right, at the basic level, right? And you actually can tell me what are the side effects, right? So if it comes, here's a new pill, you can prescribe it to your patients, right? It means that it has gone through a clinical trial on real people, right? It means that the actual manufacturing process is tested, right? So if you say that, this pill includes these 12 ingredients, right, and that's how you cook it, that's exactly how you do it. And there's some people who actually go and check. And the thing is with, AI in healthcare is right now like nobody checks, right? People like us, we put stuff in our notebooks and we deploy it, right? And that's really how it works, right? I mean, if we're really good about it, we version the models, right? Or we have some experiment tracking, right? If we're like, at the top end, okay? But there's a mismatch of expectations there. And I think that very, very quickly we can do better here. So that's the goal in that respect. And I do expect fairly quick progress. Because one of the things I like about the really healthcare in general, compared to, I've worked in e-commerce, I've worked in finance before, the level of ethics is actually much higher. And on one hand, yes, healthcare is slower, right? And it's slow because it's slow period, and it's slower because you're just talent and money goes elsewhere sometimes. But one good thing with healthcare is when you put a system, version 1, day 1, it's going to have all of the ethics and safety and regulatory checkboxes, right? And that's just a different mindset and a different thinking, right? And I think healthcare may actually be able to lead other industries, right, in that respect.
This is excellent. I know we're a little bit tight on time, but I did want to squeeze in one more question before we lose you. From your perspective, I mean, you've given us this wonderful background about the responsibility. I'm just curious from the context of like basic hallucinations. Like, do you feel that like these systems in place are going to help prevent or reduce hallucinations, or do you think there's a whole other set of worries that we have to now take into account of?
Sure. Yes. So, clearly, I mean, the way we are designing our kind of a medical chatbot system, it's designed from the ground up to never hallucinate. Okay, and that's a key requirement, because if I'm a doctor and I ask you questions and I'm not sure, it's like, look, like you haven't helped me at all, right? I need to go check, right? So you can say, look, did this patient start taking this drug, or do you recommend that this will be done, right? It's like the whole point of the system is that I don't have to go into my electronic medical system and go, tab by tab and find the answer, right? Or ask someone else. If I don't trust you, I still need to do it, okay? And a lot of what doctors do in hospitals, by the way, and nurses, they do a lot of it because they mistrust things, right? So like you come in, here are my labs. Okay, we're going to do new labs. Okay, now they're not trying to annoy you, right? Just come and says, look, this other thing that happened 4 days ago, I don't know if you were fasting before, I don't know what happened, I don't know who drove you, right? I don't know how they tested it, right? It's like before I, kill you, right? It's like, I'm going to annoy you with one more blood test, right? So they're very careful with that for good reason, right? Because, once you kill one of your patients, you kind of, you become very careful that way.
Yeah, fair enough. Yeah,
yes,
that's important, I guess. Yeah,
yes, just for your own, self-esteem and ego, and those
exactly. If for no other reason, exactly. Okay, fair enough.
Exactly, for no other reason. Yes. So, but in the sense of system, really, they're not helpful, right? So the way we design a system is that the LLM does not, when you ask it a question, basically it does not give you the answer. It generates a query and it goes and looks into a knowledge base, right? So really what you want is, look, take this context, really generate, it could be a SQL query, it could be, an embedding query to a vector database, right? The point when I ask you a question, no, you generate a query, you go to that knowledge base, you only answer from the knowledge base, okay? And that, so that gives me two things. First of all, I can explain everything, right? So why do you say that this drug has an interaction with this other drug? Well, it's in this paper, okay? It's like, why do you think this patient is diabetic? It's here. If you don't find it, it's not there, right? So in a sense, if I ask the model, what's the capital of France? Like, if it's not in the database, please answer, I don't know. Okay, right? Because that's the level of trust that I'm looking for, right? Because I only want you to look here, right? If it's not here, it's like, please, like no creativity, right? It's kind of, no, and LLMs, they have use cases that are all about creativity, right? This in a sense is the other extreme, okay? The other huge benefit, and we are seeing this really with doctors playing with this, is that when different doctors ask a question, depending on the context, they mean different things. Okay, so let's look at a super simple thing like, is this patient diabetic, right? So depending on the context, right, it's maybe they're diabetic because they're taking medication. So look, they're taking medication, I assume they're diabetic, and the doctor will say, no, this people use this for weight loss all the time, don't do it, right? And maybe they're diabetic because they have these 2 abnormal H1C test results in the last 6 months, and here they are. Okay, cool. There may be, but another comes and no, this is for billing. It doesn't help me. If you don't have the diagnosis code, then they're not diabetic, right? Or they're not diabetic for Medicare, right? Because someone didn't put the code in, right? So really when people ask the question, they're asking very, very different questions, right? And by the way, a lot of the people right now who do the SQL stuff, right? When you email them and they come and say, oh, when you mean diabetic, it's like, there's a reason why this becomes 2 pages of SQL, right? Because there's a whole lot of context behind your question, right? In this very specific context. So a lot of the way we see people using those systems is they ask a question, they got an answer, and the guy's like, why? Why do you say that? And they look at the results and go, no, that's not what I meant. Okay? Or now remove the pregnant ones, right? Or even like simple stuff like looking up medical papers, right? Is this protein a good inhibitor for this gene, right? And you get the papers, right? But then sometimes you come and say, no, look, I only want human trials, right? So if this one on Mars is just not good enough for me, right? Or look, this study was on like 76 people. Come on, man, right? Only giving ones that are 500 and above, right? Or this is from 1997, right? I don't even believe the lab work, right, from that time, right? It was very early on. So that's another reason, really. If kind of if you just give an answer, it's almost useless, right? Yeah, but other than that, just knowing that medical answers are not coming in from Reddit, but from actual documents you put in. That's also useful. So you put your own medical guidelines, and you know what's there, right? And you know what you trust. That by itself gives people some comfort. And yes, and with us, I would say yes, we by design our system will not hallucinate. And for this, and of course there are other use cases we want it for this specific use case. So it's an absolute business requirement.
As a patient, I'm very glad that the medical field has a lot higher bar in ethics, and your system has been designed from the ground up to not hallucinate. So kudos to you and the entire team.
Yeah, look, and that's the one thing in healthcare. We're all patients, right? It's like, one day I'll go to a hospital. And it's like, oh, wait a minute. Can you print this on paper? I want to read this before you give me the medication. Yeah, so you really want these systems to work well, yes. And if they don't work, yeah, you often come and say, like if you go yourself, if you take your kids, no, I'm actually okay with 3 people reading this manually and triple checking everything. That's I'm good. I'll wait. Yes. And look, one of the things to like about really, healthcare, really, it's slower, it's highly regulator, many, there's politics, there's all of that. But say one thing, definitely the standards of ethics is higher. And a lot of the people who are in healthcare are there really because they really want to do good, right? Like, nobody goes to healthcare for the money, right? Or for the fame, right? People go into healthcare because, they feel like, this is what they do in life. And I think really as someone who's working under industry, it shows up daily.
Awesome. Well, thank you so much for taking the time to join us on Databrew. Few shout outs for everybody. Try out SparkNLP. It's an open source library, and you can also contribute to it. And 2, check out the Jon Snow pub in London if you happen to be stopping by London. Thanks, David.
Thank you very much.